Alright, welcome back to your video under integration of hyperbolic functions. Integration of hyperbolic functions, and under this video, we are also going to learn an interesting stuff. Alright, good. So, straightforward, let's move on. Now, as we said, integration is a reverse process of differentiation, and for that matter, we establish in differentiation that when you differentiate sinus, you get cos. That means that when you integrate cos u du, you are going to get the result to be sinus u plus c. In the same way, when you integrate sinus u du, the output is going to be cos u. And I hope you can continue with it. Sec square u du is going to give you times u plus c, and also cosec, negative cosec u cot u du will be also giving you cosec u plus c. But remember, when you negate both sides, this will go and you negate this side. Good. Also, since it's a reverse process, when you integrate sec u tan u du, you are going to get the result of sec u, but you negate it. Negative sec u plus c. Alright, so as a reverse process, that is going to be your result. What is left? Okay, that is cot, how do you pronounce it? Cot u. It will be also giving you negative when you differentiate cot u, you are going to get negative cosec square u. That means that when you integrate negative cosec u du, you are going to get negative cot u. So that is going to be that. Alright? Very good. Now, let's see how we are going to solve some of the questions as far as this idea is concerned. Alright. So let's start. So let's first have our example. When you integrate sin s cot s as respect to s, what are you going to get? Hope you can start with something, alright? You can pause the video and try to resolve it. Okay. Now, as I told you the other time, that there are some cases that you'll be having an integral function whereby you'll be having the derivative of the what? Of the function. So you'll be having the function and its what? Derivative inside. an integral function can be in terms of a function and its what? Derivative. So, having this, you can see that whenever you differentiate sinh, you are going to get cos. And whenever you differentiate cos, you are going to get sinh. Please be careful. I know that when you integrate sinh, I know that when you differentiate sinh, you get cos. And when you differentiate, when you integrate sinh, you get negative cos. But when you integrate cos, you get sinh. But here, the negative don't come, whether cos or sinh. When you integrate sinh, you get cos. And when you integrate cos, you get what? Sinh. Alright. And for that matter, in this integral function, we have a function and its what? Derivative. Very good. So you can choose to set u to be whether cos or sinh. We all end up getting the same answer. And du will be equal to sinh s ds. Alright? Or du over ds is equal to sinh short s. And you can see it probably here. Oh, very good. See, you can write it as cos s sinh s ds. Wow. So the whole of this is exactly what? Du. And if you choose your u to be equal to sinh, you also end up getting something like that. I hope it's clear. Or you can also choose to make ds the subject, and it will also come and cancel something out. It's still the same idea, okay? So having this, we go by getting, we know that u is this, so u times the whole of this is what? Du. And in fact, please don't forget this concept. Sometimes you see 8 dividing, sometimes you see 8 multiplying. It's still the same thing. So here, you get u squared over 2 plus c. And that is what we have for that. So simply, we get cos squared s over 2 plus c. And that is our end result. Very good. Next question. We can also have a question like integral of cos squared s, cos squared 3s sin 3s ds. Now, looking at this question, the arguments are the same. Very good. So here, we have the argument to be the same. So we can now first set our u. Alright. So we can because we know something like integral of sin s, cos s. Alright. Or we made it u, no worry. We know that of u. Like what I mean is that we know we don't have a case where we have a coefficient being a value there. Alright. Oh, but if you have cos s, the coefficient is 1. Alright. So it's a value. I mean that the case where the coefficient is not more than 1. Alright. So here the u is 3s and the u is equal to 3 ds. Okay. So ds is equal to du over 3. So the integral of cos squared u sin u du over 3. Seeing what we have there. Oh, I am playing a question. No worry, let's continue. See what we have there. We have integral of cos square u sin u du. And the constant we have there is 1 over 3. Alright, so having this, we can now set another u. We have to set another what? Substitution. Because we still don't have it in a form that we know already. We still don't have it in a form that we know already. Hope you can see that. But here, since we have already used u, we can't use u again. The fact that we do use substitution doesn't mean it's always u. So here, we can choose to let. Also, in the same way, we are having a function, the whole integral function. We have a function and its derivative inside it. So we say that w to be equal to cos u. And when you differentiate w over du, I hope you know that dependent and independent variable is u. And that's going to be sin u. Or the w is equal to sin u du, and that is exactly what we have here. So 1 over 3 integral of cos square u, and the whole of this is dw. But we know that, oh, what is wrong here? We know that w, there's something wrong somewhere. Alright, so this is w, and we know that this is the same as cos square u. Alright, and w is equal to cos u, cos u. So here we get w squared. W. Very good. Very good. At times, you also know what you're doing. So here we get 1 over 3, and when you integrate this, now you see it's in a form that we know already. So here is R1 here over 3. Over 3. Okay. Plus C. So here we get 1 over 9 w to the power 3 plus c. But w is what? But w is cos u. Cos u. And we also know that, or let's do the substitution, 1 over 9 cos u to the power 3 plus c. Alright? But we also know that u is what? 3s. 3s. Therefore, we can get, by substitution, we can get 1 over 9. We can get 1 over 9 cos 3s to the power 3 plus c. So that's going to be the final result for that. Alright, now entry to find out more questions from any book that you have it available. Okay? Let's look at another case. Let's look at the inverse hyperbolic. inverse. So we are going to look at integration of inverse hyperbolic functions. Inverse hyperbolic functions. And with that one, when you integrate 1 over, please here be careful. Because inverse hyperbolic function is not the same as inverse trigonometric function. Alright. Giving you these two. You see the signs are changing. Be careful with the one at inverse trigonometric function. Alright, but here we know that sine inverse is what? Ln. So here we know that it's ln s plus square root of s squared plus 1 plus c. And here too is the same as ln s plus square root of s squared minus 1 plus c. Alright, so let's look at 1 or 2 examples. There we go. In fact, let's look at one example and let's go away, right? The idea of solving it is the same as the one that we did at inverse trigonometric functions. So let's solve ds over square root of 4x squared minus 9. So having these two integrate. Please don't forget that this all that will be, it can be a case that you'll be having it in a definite what? Integral. Okay. It can be a definite integral. So I can clean this. Alright, let's continue. So, having this, let's start solving. Solution. This is the same as 1 over square root of s squared Alright, so now, looking at the formula that I gave to you, you see always the inside, this inside is relating to something like s minus or, now I don't use the s because the s can be a function, okay? So, let's say u squared minus 1, something like 1 should be inside. So, what we can do to what we have here is that we can factor out 9 here. And you know something? If you want to factor out 9 here, then you have to multiply this by 4s squared over 9. So that when you multiply this by this, it will not cause any problem. And you are going to get back what you have here. So minus 1. This is acceptable. Yes. Alright. And now we know that Square root of this 9. This is like this, algebra. Square root of 9 times square root of this. We can write this as 3s, 2, because 2 square is 4. So 2s over 3, because here we can get 3 squared, all squared. So we have factored the square out, minus 1 ds. And with this is 3. So we can get 1 over 3 out, 1 over 3 out. Then we get that place to be 1 over square root of 2s over 3 all squared minus 1 ds. Very good. And now that we have a something square minus 1, we can let our u to be equal to 2s over 3. And when we take the u, you are going to get the u over ds, you are going to get 2 over 3 dx. We have divided it already. So from here you make dx the subject, and we are going to get dx to be equal to 3 du over 2. Alright. Now, by substitution, we get 1 over the integral of u squared minus 1. Beautiful. We are getting something interesting. And dx is 3 over dx is 3 over 2 du. 3 over 2 du. Alright, so now you can see 1 over 3 will multiply 3 over 2. And the integral of 1 over u squared minus 1 du. In fact, we are transforming it to look like what is already in the what? In the formula I gave you. Don't forget, don't worry about here we are having u and then we are having x. It doesn't matter, okay? Just know that it's a function. Alright, so here we are going to get this will cancel this, so we get half integral of 1 over u squared minus 1 du. But we know that this is what? Koch inverse. Therefore, we get half Koch inverse of u plus c plus c plus c plus c. We are not yet done. We are simplifying it to the least. To the least. Therefore, now we know that u is equal to 2s over 3 plus c. Alright? But we know that Koch inverse of s, but I would like to make it Koch inverse. Don't worry. Let me take it. Koch inverse of s is equal to Koch inverse of s is equal to s plus square root of s squared minus 1. Alright. So by substitution, wherever since you know Koch inverse, you don't have to leave your answer in that form. Alright. Make sure you simplify it to the least. Now, wherever you see this s, is now not going to be s, but rather 2s over what? 3. So I would like to put this as a squared. So here, but a is equal to 2s over 3. Alright? So by substitution, we get half ln a 2s over 3 plus the square root of 2s over 3 squared minus 1. Alright, plus c. Beautiful. So that is exactly what we have. Oh, I love maths. Now let's apply our algebra here and move on. Here we know that we can get 1 over 2 ln 2s over 3 plus square root of here, you are going to get 4s squared over 9 minus 1. Alright? Plus c. Beautiful. Still algebra. Continue. Ln 2s over 3 plus here we are going to maintain the same or common denominator. So the one here we are going to write 9 over 9, right? So 4s squared minus 9 over 9. Alright, please, I'm going to do it straightforward. This one is the same as that. This is the same as 1. So I'm going to clear it, and write 9 all over 9. Alright, very good. So we continue the algebra. You have to clear off to the least form. Alright, to the least form. So here you now get half ln. Okay. So here we now get 2s over 3. I can see something. No. I want to quickly write it. 4s minus 9. All these over square root of 9. And that is 3. Plus c. And watch. We have achieved common denominator. So half ln can we forget that? 2s plus square root of 4s minus 9. All these over 3 plus c. Right? And even if you want to still continue, you can still continue with it. Okay? You can still continue with it. Because we know that from our indices, when this is divided, pure algebra, when this is divided, you can get half ln. I will not end it. Let's continue. 2s plus square root of 4s minus 9. Don't forget, you're not doing only calculus. That's why the prerequisite of the algebra should be algebra. And here, since it's dividing, minus ln 3 plus c. Okay? Plus c. So that is what you're going to get for that. That's what you're going to get for that. And when you reach this side, know that here, this half will affect the inside. So you get half ln 2x plus square root of 4x minus 9. There minus half ln 3. Please don't punch your calculator. Plus c. Now watch. What does a constant means? Constant means a constant. So everything here is a constant. Let me ignore the negative there. Everything there is a constant. So in all, we are going to finally get half ln 2x plus square root of 4x minus 9 plus c. You can make it minus c or plus c. It's still a constant. So everything resolves to what? A constant. And that will be the final answer for that. Wow! Woo! We love mathematics. We love mathematics. Alright. I think that is all. Make sure you find out more questions in itself. Until then, bye-bye. I have forgot to introduce our next topic to you. In fact, it's going to be interesting. We are now going to enter integration techniques. We are now going to do calculus 2. That is integration techniques. And then we are going to start. In fact, all these that we are doing, they are all techniques, but we are not going to enter techniques.